Hello. In this question, which is the third part of the question that I've been working on, I'm more interested in instead of the process of solving rather than just getting the solution. Here we are interested in finding the area of this field. Let me just put this down. Our objective is to find the area of this field, area of the quadrilateral PQRS. Of course, we can find this using the formula for the trapezium, if you know it. But I will suggest that go through this process. I can always make a video for going through using the area of the trapezium. But it's always preferable that we learn the more basic note. I'm going to try and find the area using the bases as triangles and rectangles. But during the process, we're going to face some hindrances, some obstacles, and we will try to resolve it one bit at a time. Here I'm going to make this perpendicular from the point R as well, and this will break down the figure into three zones. Let me call this point as Y. The left extreme is a triangle, and you see, so first extreme is a triangle, that is PXS. The second one is a rectangle, that is XYRS. Meanwhile, the third one is again a triangle, which is RYQ. Finding the area of the quadrilateral requires make us to find the area of these three pieces, put them together, and that should be what we are wanting. But what are the hindrances? Let me help you recollect the area of a triangle. Area of a triangle is given as a half the base times the height. So now if I look at the first triangle, now you'll notice that we did find the height in the last question. Okay, we found it to be as 282 meters. And you can always go back and check that. Meanwhile, the length px is what the question is. This is what we like to find. That is your base. Now, how do I find this? Now, we had already used sine in order to find the height or the perpendicular distance. So we can find px with another trigonometric ratio. Think on it while I get to the next rectangle. The rectangle again has, so in the first part, let me just put this up. In the first part, the first hindrance is to find px. The second is a rectangle, which is XYRS. If you may notice, being a rectangle, the breadth is already known to us, which is 282 meters. What is not known to us is this length, XY. If we are able to find this, we can find the area of the rectangle by merely multiplying the length with the breadth. So remember, but now that this 450 meters that I have placed over here is a total length PQ right across. It is not XY. So so my plan is, how do I find XY? My plan would be to find XY, but I need to find a way to that. Likewise, the third one is a triangle RYQ, this triangle here. And the question is, how do I find? Again, if we use the area of the triangle, that's half into base into height, wherein I have RY, which is already known to us, the same 282 meters, because that's a rectangle to its adjacent side. And I like to find YQ again in that process. So finding YQ would be the problem here. Let's go on and try to find the first piece, that is PX. PX, I could find PX. Let me have a small change on the color. And yeah, there we are. How do I find PX? I could use the cosine, the cos of 70 degrees, because it associates the base. We happen to see PX is the base of that triangle. So that is a PX over the hypotenuse, which is still 300 meters. Therefore, the PX would be equal to 300 times, pardon my handwriting over there, times cos of 70 degrees. Use a calculator to find that. So that comes out to be, that's a cos 70. That's 102.6. That's equal to 102.6 meters. Having this knowledge, I can find the area pretty easy. So the area, so that's my first problem, first of the problem that I just resolved. Okay, we'll look into the area a little later. Let me resolve the second in the problem, that is to find xy. I already have found px to be as 102. Let me just write it in the clutter, it may help us a little. And so now if you may notice, SR, this length up over here is 250 meters. So which would mean that xy is also a 250 meters, that being a rectangle. So that clears my problem, and xy is pretty much found, and that is equal to 250 meters. So that's a rectangle. And now the last piece is to find YQ. I know now that the total length is a PQ, which is 450 meters. I have a PX and an XY. I take the sum of that and I subtract it from 450. So less PX and a XY. So from the 450, there's a total length, that is PQ. I'm reducing the PX and the XY. So that comes out to be 450 minus 102.6, or rather is it 102 point, I'm just confirming. I believe so. Oh, we did that. I'm so sorry. 102.6 meters, I believe, and plus a 250, which we just found. We do that and we get our answer. Let's check on that. How much is that? So that comes out to be 0.6 plus a 250. I complete my bracket, and it comes out to be a 97.4 meter. Okay. Now comes out to be the last part on finding the areas. We already have the area of the triangle, the first triangle again. And what's the name for that? I'm sorry, I have to make it to move up. So this is PXS, which is equal to the half times the base, which is which is 102.6 times the height, which we already found, which is 282 meters. So you use your calculator to find that, and that comes out to be times 102.6 times 282. That's 14,466. Sorry, 0.6 square meter. That's the first piece of the information. Second piece is a rectangle. So that's a length into breadth. That's 250 into 282. So area of the rectangle, that comes out to be a 250 into 282. So that's area of the rectangle. And we see that comes out to be 252 times 282. That's 71,064 square meter. And the third piece is area of the triangle again. It's called as RYQ. That's half into, the height was again 282 times 97.4. So that comes out to be 282 plus 97.4. I'm so sorry, I made a calculation error there. Times 97.4. So there we are. That comes out to be some 13,733.4. And I'll leave you with the task of adding up these three in order to find the area. Okay? I hope you enjoyed the video.